Okay, here we are looking at the first question in Pure Mathematics Year 2 from the Edexcel course, Mixed Exercise, Book 2, page 19, on the Algebraic Methods chapter. And the first question is, prove the square root of a half is an irrational number. And they say to prove it by contradiction. Okay. So they're giving us a big clue by saying prove by contradiction. So let's start by assuming or making the assumption that the square root of a half is equal to a over b, which is equal to a rational number. Okay, so let's prove that it is rational, or maybe we will look at that. So let's have a look and see what we can do with that. So by taking the fact that we know it's a rational number, okay, let's assume that, then we can write it as two things. So rational number, and A and B have no factors, okay, because they are, it's been cancelled down to as low as it can go. Rational number can be written as a fraction. So A and B have no factors, or no common factors. No common factors. Okay, let's start then. I am going to start by saying I'm going to square both sides, and I'm going to say a half is equal to a squared over b squared. I'm going to multiply the b out to get the a squared, and then I am going to say that the b squared is equal to 2a squared. So since b, so from that I can say that b has a factor of 2. So b is an even number. Okay, if b is an even number, I can say that b is equal to 2n, going back to that GCSE notation that you can write an even number as 2 times any other number. Okay, so with that in mind, I can say that 2n for b squared is equal to 2a squared, which of course is 4n squared is equal to 2a squared, and of course dividing by 2 I can say that I can say that 2n squared is equal to a squared. So again, we can say that, now just realized I made a mistake up here, I can say that b squared has a factor of 2, so b is an even number. And in the same way, I can say that a squared has a factor of 2, so a equals even, and because of that, that means that we can say that, so we were saying at the beginning that a over b has no common factor, but it contradicts because we just showed, because not 2, a and b are even and have 2 as a factor. So the square root of a half does not equal a and b of a rational number. And must be. And so square root of a half, or thus square root of a half, must equal an irrational number, because that's its only other choice at the moment. Okay, so because we have shown that we cannot write it as an a over b fraction, because as we worked that through, we ended up finding out that they both had to be even numbers in that case, then we can't do it, and so the square root of a half must be an irrational number. Okay, right.